Hello and welcome to my channel. I'm Bound to Be Coding. In this video, I want to present to you a new system that I've added to my game that allows me to manage clicking on and working with objects in my game. For this video, I call this system Click This, Do That, and it is a scalable object action system, and I want to share the approach with you if you are working on a game and need a way to associate actions with objects in your game, then maybe this approach will work for you as well. Just a quick overview of this video. I'm going to present to you the user story behind this feature. We'll look at the requirements and the system design. I'll show you the design loop. We'll do some code review, and then we'll see it in action. So the user story for this, for my game, my user story, which is a user story is simply a purpose for the feature. It describes what I want the feature to do and how I want it to work and the value that feature has in the game. So for this implementation for my game, here's my user story. When I click on a game object, I want to be able to have one or more actions that I can choose to perform on the object. I want the actions to be represented by buttons on a button bar. I want to use the same button bar for any object I click on. When I click on a button, I want to perform the action, and then I want to see, I want to hear, and know the results of my action. If I move my character, the button should reset. If an option is no longer available for that object, the button should reset as well. Now the requirements for this feature are that it be intuitive, simple, and rewarding. I want one centralized button bar containing 12 potential actions, and this is my own developer imposed limitation. I have 12 buttons. I could expand it later, but for now, 12 will work for what I want to use this for. The actions are going to provide progress, sound, and randomized results. Hopefully that will make it rewarding and intuitive and easy to use. I also want it to be scalable and flexible. This system needs to be easy to implement and flexible enough to handle the specific needs of any object in the game. So if I click on a tree, this system needs to work for a tree. If I click on a campfire, it needs to work for a campfire. If I click on a house, it needs to work for a house. So I want the system to be scalable and I want it to be flexible. I say scalable because I can imagine in my game there's probably going to be hundreds, if not thousands, of these actions that need to be performed against objects in the game. Now the system design is this. I have a button bar in the game. It is in the bottom center part of the screen, and the top portion of that is basically an information text which describes the object clicked. So you can see over here I have a tree, and when the mouse clicks on the tree, I get object information about that object. It is a spruce tree. When I click on an object, and I will then see all the possible actions. Those actions appear below the object information in that first set of buttons at the top right here, the actions. So the top row of buttons are going to show available object actions, and each object in the game is going to have a different set of actions. And so as I click on an object, I get the actions available for that object. And when I click on a button, it'll perform the associated action against that specific object. This bottom row of buttons is a context menu, and this is where I will have access to windows that pop up in the game, other other features in the game. It's simply called the context window, but the action window is the one that I'm focusing on in the the action buttons are what I'm focusing on in this video. Let's talk about this user interface that I just showed you. It is responsible for loading the buttons with the appropriate action sprites, and it also alerts the system when a user clicks on a button. That's the user interface part. That's the UI part of this system. The second part of it is an object action engine. Now that's a singleton. It is a class that's auto-loaded as a node whenever the game runs. And if you are familiar with singletons, you know that these singletons load at the top of the scene tree and are available anywhere in the scene tree from any scene. The object action engine stores object actions in a dictionary, and those are loaded from a JSON file. The engine manages the current object action that is taking place. So I have an object action instance that's stored in the engine. And since you can only click on one object at a time and work with one object at a time, the current object is stored in the singleton in the engine so that I can reference it when I need to. Alerts, the object action engine alerts when the UI reports a click. So whenever the UI clicks, the object action engine is alerted and then proceeds to pass information to the rest of the system. It also handles the common workflow for processing that action. Then we have the actions themselves. Now these are instanced and isolated custom code. Each action is its own thing. It does what it does and it's isolated. If I need to troubleshoot, one particular action, I can jump right to that code and I know that more than likely the problem's going to be with that one piece of code. And the action code, the instance isolated behavior, reaches into any other system in my engine that is required for that action to take effect and to make changes to the game. So that's the system design. We have a UI, we have a object action engine that is accessible from the UI and from the actions themselves, and it links everything together. And then, of course, we have the instances of the code for each action that is to be performed. Now, the UI has a couple of scripts, and I will show you those in just a minute. We have a target bar, which is the script that is attached to the button parent. So you remember I showed you the target bar where the buttons appear. That object, that node has a script attached to it, and its job is to manage the loading and unloading of those buttons and the processing of those buttons. Then for each one of the buttons that appear in that bar, there's an action bar button script. Now that script is attached, the same script, to each button. There's no difference in the script. They all are all the buttons have the same action bar button script associated with them or assigned to them. Then we have the engine classes themselves. These are part of the singleton. So we have the object action engine. This is the auto-loaded singleton. We have an action button, which is the button information for a button. That is a class that holds the information about the button. And then we have an action definition. This is a static action definition. It's loaded from JSON. It's stored in a dictionary in the object action engine, and it basically defines some properties for our action. Then we have an action instance. This is the instanced action data for the current action. It is also referenced from the object action engine. We have a response that comes back whenever an action is finished, and that response information comes back from the action and is used in the engine. The action result is it's basically an enum, enumeration that indicates a success or a fail or not possible. It basically tells us what happened in the action and what was the result of the action. And then we also have an object type enum, and that is used throughout my game. It basically identifies the type of object being clicked on. I group objects, like for example flora. They are in a different an object type, and we have other object types in the game. And so this allows me to associate the object with a specific type. Now we have one scene in this. We have 9 base scripts that I just showed you. We also have an unlimited number of action scripts. We have 6 pure C# classes. Those are there for managing data. We have one scene for the parent, one for the buttons. Again, the same script. One singleton auto-loaded, that's the engine, and as many actions as we need. The technologies I'm going to discuss in this video are Godot, of course. I'm using right now version 4.3. And all the code you're going to see today is in C Sharp. We're going to talk about reflection, and we're also going to look at some JSON. Now, the design loop, we'll talk about that for a second. So here's what happens. A user clicks on a world object. The mouse event on the object calls the engine to set the actions for the object. So when I click on the object, I need a set of actions. And so I'll capture the mouse event, I'll pass it to the engine and say, hey, give me the actions for this object. The engine calls into, and I'm using as an example today, my Flora engine. So my action engine is going to call into the Flora engine to get all the possible actions for the particular object that I clicked on. And then it's going to load, a load new action event is going to be invoked. The target bar is subscribed to this event. It's listening for these actions to be loaded. And when the event fires, it gets the action instance and loads the buttons with all of the possible actions. When a player clicks on one of the buttons, the button reports to the target bar which button was clicked. And then the target bar calls the engine and says, hey, this button has been clicked. We need to process the action that's associated with this button. The engine then uses reflection to instantiate the action object. Remember, I said that these actions are isolated code. And so it's going to instantiate an instance of that code. The action is added to the scene tree. And even though there's no visible node that is shown in the scene tree, the action is added to the scene tree. And the reason I add the action class to the scene tree is because the action, the code inside the action, needs to access other nodes in the game. And in order to do that, I need to add it to the scene tree so that it has access to all the other nodes in the scene tree. The action's initialization and perform action methods are called, respectively. Those are methods that I wrote that are called, that are common to all of these actions, and you'll see how that works. And then we'll call the perform action instance, and that will affect change in the game based on whatever the code is for that particular action. When the action has updated the game's state, whatever the action is supposed to do to the game to change the game, that's going to happen in that code. And then once it updates the game's state, it reports back to the engine a response. And then afterwards, it is disposed of. It is removed from the scene tree because it's done its job. The engine then shows the player the results of the action by means of visual audio responses to what has taken place. The game clock is then advanced based on the time it took to perform the actions. So in my game, when the player is moving around the game world, the game clock is being advanced. But every time the player stops moving, the game clock freezes. And I chose this approach because I want the game itself to have sort of a strategy feel to it. I don't want the player to be presented with a grizzly bear and then panic and not have time to think and calculate the next move. And so in that respect, it's kind of like a board game almost. But the idea is that when the player is not moving, the game clock is not advancing. But when the player performs an action, of course, that action needs to be tracked, and we need to subtract or add time to the game clock to reflect the time it took to perform that action. And this produces a visual cue where the time and the quantity are shown in a fade out over the character's head, and you'll see that. And then step 2 is called again to reset the action bar to the new set of actions. So for example, let's say a tree has 2 sticks and the player tries to collect those sticks and the player gets 1 stick in that action. So they click the button, they get 1 stick. That means there's 1 stick left to be gathered from the tree. So that button that represents the action for collecting the stick or getting the stick will remain on the button bar. But if that action resulted in 2 sticks being retrieved, then that means there are no other sticks. So if that's the case, that button needs to disappear because there are no other sticks on that particular tree. And that's what happens with step 2. It's called again to reset the action bar to the new set of actions. Hey, what do I have left on this object? And then when, of course, when the player moves, the action bar clears the buttons out as well. Okay, well, with that introduction, let's go ahead and step into the code and take a look at this system. All right, here we are in the game code, in the code behind. I'm looking at the Flora object class, and what we're looking at here is the input event. This is where I capture the mouse event for the Flora object, and I process that event. Now you'll see it says if the event is a mouse button and the button index is the left mouse button, then we do some things. We check some distances to make sure the object is close enough to the player for them to actually be able to reach out and touch it. But what I want to draw your attention to is the line 79 here, where it says else if is pressed and not is shell. So this is a tree. It's not a shell tree. I think I covered that in another video, how I handle hundreds or thousands of objects in a game and load them all with information. That's a subject for another video if I haven't done that already. But what I want to draw your attention to here is the object action engine, where I'm calling into the engine and I'm setting the object action, set object actions. Now, this is the first step in the process of handling object actions. So I'm going to control click here, and I'm going to jump to the object action engine. This is my instance, excuse me. Let me jump back down here, and let me jump to the, not the class, but the method. All right, so here in the object action engine, we have this method called set object actions. We bring in the type, the object ID, which is the ID of the object that was clicked on, some other properties that we're sending, or other information that we're passing into this method to process this action. And so if the object is deleted, I'll show you why an object would be deleted when the object is clicked on. But for now, we have a little if statement here to take care of that. We're getting a list of string, which is an action list. We are setting some item info, an item info variable, and we're getting a button action data list. We're instantiating that a new list of action button. And if the object type is an item and it's a container or a liquid, so it's an item or a container or a liquid, we're going to do something. Otherwise, if it's a Flora, well, we're going to do something with Flora. So the action list that is going to get populated is from the Flora engine, since the player clicked on a Flora object. And it's Flora engine get object actions. So I'll just click on that. So here we have in the object action in the Flora engine the get object action method. And what we're basically doing is we're checking to see if the dictionary that has stored all of the Flora definitions contains any actions associated with the type of object that we have clicked on. And this is just various if statements where we're checking for individual objects that are or that belong to the instance of the game object that I clicked on, the Flora object. Okay, if that sounds confusing, I apologize. Kind of doing this off the cuff with describing this engine and trying to see if I can convey this information to you in an intelligent way. We'll see how it goes. So let me jump up to my resources, my data. This is where all of my JSON files. This is all static data that is part of the game. It doesn't change, and it collects information that I need in the game for each type of different object. So let's go to the Flora definition real quick. And this is my JSON file for, for the Flora objects in the game. All the Flora have these properties associated with them, and each one is different, and each one has different information. But I want you to notice that, for example, the apple tree has a set of actions associated. And this is what we're tapping into in the code that I just showed you in the Flora engine, where we're loading the actions. So an apple tree is going to have a study. So far, I haven't finished all of the actions yet, but that's what's the beauty of this system is I can build on it. I can add a new action, then I can associate the action with this apple tree or this birch tree or any other tree in the game by just simply having a comma separated list of string values called actions. So I have study, break off branch, gather sticks, scrape fiber, pull up seedling. So these are the actions that I have coded so far for uh, example for the apple tree. And the engine is basically saying, hey, give me all the object actions for the Flora object that I clicked on. So I get the object ID, I get the definition. The definition will then point to the specific type of object that I have clicked on, like if it was an apple tree. And I'm getting those actions, and I'm splitting that list. That JSON file has a comma separated list of string values, and I'm separating those by the comma so that I can get my list of actions. And once I do that for all the various types of things that I can do with Flora, I'm going to return that action list back to the caller. All right, let's go back up, and I have one reference here. So we have our action list, we get our Flora actions, and we load those actions. Then the item info is just some information that I'm passing. Uh, I'm getting the Flora name from the object, so that in my menu in the UI, when you click on the object, it's supposed to tell you what the object is, and that's what this is. The item info is getting the name of the object so that I can pass that back um, to the UI so the UI can show. Then I go through the action list, and for each one of the actions that show up in the list, I create a button action data list. Action button is the class, and the action button basically just has some information about the action. It has the name of the action that comes from that JSON file. It has a button ID, it has a button texture, and it has a tooltip. Now, this action button, this class, is basically passing information back to the UI about the object clicked and the name of the action that needs to be represented in each one of the buttons. And so you notice there's no ID for the object. There's not information about all the particulars of the Flora item or whatever the object was that was clicked on. This is just enough information for the UI to be able to do its job, and that's all. So this is what we call a DTO, a data transform object. We are loading a class with information, just enough information for the UI, which is going to be getting this class, for the UI to work with the system. Doesn't need a bunch of cruft added to it. It just needs these four properties. So far in my design, these are the only thing that are needed for the UI. And then we, of course, create a action instance, the current action instance. This here in the object action engine. This is the reference to the object that was clicked. And since we can only click on one object at a time, this guy gets updated each time an object is clicked in the game. And we're storing this. This is a variable in the object action engine. And we're storing the information about the object clicked so that I can reference it later. So I create my action instance, I get the information, and then the code then calls the onLoad new action instance event handler, this guy right here. And this is just below it here. on load new action instance event handler. So in the event handler, we're going to invoke. What we're doing is we're invoking this event to say, hey, we have a new current action instance. We have something that needs to be updated in the UI. And of course, the UI is subscribed to the load new action instance event handler. So if I look at my references, um, I see that we have in the object action engine, we have these references here. And I don't want to chase a rabbit per se, but I do want to mention this. If you're wondering about um, setting up events in C Sharp, it is really, really easy to set up an event to listen for something or to announce something to some piece of code somewhere else. So the object action engine currently has two event handlers that are created, and here's how you create them. You create a public event and you give it a name, okay? And it is of type event handler. All right, so I have a load new action instance event handler. I have a load key commands event handler. This guy is my new project that I'm working on, where I want to have hotkeys in the game, and I want to track those keys, and I want to use those keys in my action engine, object action engine. That'll be for another video. But the load new action instance event handler, if we look at that and we do a search on it, you will see that I have a private on player engine player moved event handler that is calling this on load new action instance event handler. So remember I said that if the player moves, I want to clean things up. I want to reset that button bar so that it doesn't show the object actions. Well, that's what this does, because what it's doing is it's setting that current action instance to null, meaning we don't have a current action anymore. And when does that happen? Well, it happens on that event gets fired on the player move. So whenever the player moves, we have that event that gets called. And so this is in the back over in the object action engine, I have an on load new action instance event handler, and this is a protected virtual method that actually invokes the event, the load new action instance event handler invoke, and it invokes the action, and that action is being listened to by other parts of the application, and in this, or the game. Sorry, I'm a developer. uh, I I am a professional developer, and sometimes when I'm talking about my game, my mindset shifts to work, and I start thinking about the application, because that's what we code at work. We don't create games at work, we create applications. So if I say that, I apologize for using game and application interchangeably. But hey, at the end of the day, they're both applications. One's a game and one's a business app. In any event, so I invoke this load new action instance event handler. All right, so I skipped down to back to where we are calling this event on load new action instance event handler. And basically, we want to take a look at who's listening to this event. Okay, so let me show you that. Apologize, I'm jumping around a little bit in my code. I'm having to pause and step away for a second and come back, so please bear with me. I apologize for that. All right, so we've got this load new action instance event handler, and I'm just going to do a find in files. I'm just going to see if I can find references to this in my game. All right, so you'll notice here we have the target bar, and the target bar has subscribed to this event. So let's jump over there. So here we have a reference to the object action instance in my target bar. By the way, this is how you reference singletons in C Sharp. You create a private type, whatever the singleton is. In this case, mine is the object action engine, and I have a private variable. And then in my ready method, I am instantiating an instance of the object action engine, and it'll get the node from the tree. So here I'm saying, hey, object action engine, I'm going to get node. The node is of type object action engine. That's very important. If I was to say get node of a different type, even of the base class of object action engine, I wouldn't get the object action engine. So it's very important that I'm casting it as the type that I am trying to reach out and get. And then node map, that's not part of Godot. That's a helper class that I created to basically map my node to whatever it is I'm trying to get to. So I have this static node map here, and my singletons, I have a reference. It's just a string reference, a constant that points where, to the specific node that I'm trying to get. And I called this static class node map. So it's not something in Godot, so I don't want to confuse you. But what I'm trying to get here is the node map object action engine. So I'm getting an instance of the object action engine, and since it's a singleton, I'm going to get the same. I'm going to get the same engine instance every time. Oops. Um, and then what I'm doing here is I am subscribing. So the object action engine has that event handler, and I am subscribing to that here by adding a, a listener to this particular event handler on object action engine load new action instance event handler. Now that event handler is right here, right down here in my target bar. And this is what is happening whenever the list of actions gets loaded. My target bar is listening for that event that fired. Okay, the event that's in my uh, engine load new action instance event handler. So it is subscribing to that event and it's listening. So here's the event listener, and what it does is it says, hey, give me the action instance in the object action engine. Remember, we saved the instance, the action instance. You can only click on one object at a time, so that's what this is getting. It's getting it. Now, if it's null, it means we don't have an object action, and so we're going to do some resetting of the UI. We're going to reset the information. We're going to reset the buttons. We're going to get rid of the display that said an apple tree, for example, and we're going to reset the buttons. We're going to clean them out because we don't have an action instance to reference. Otherwise, we do have an action to reference. And so if this is a refresh, if the bool value that is on the refresh says refresh the object, we're going to do some cleanup. Otherwise, we're going to reset buttons and we're going to load the button actions. The tween here is just a tween that I created to allow the letters of the information about, apple tree to scroll across the text so that it indicates when the user clicks on a different object, it actually does some animation for the eye to catch that, hey, this is a different object than what you clicked on previously. And that's all this is doing right here. So if you need a really simple, cool way to allow your text to scroll in a text or in a label, then you can use this code here. That's what that's for. Reset information. This is a method that basically just clears everything. This is where I'm loading the button actions in my target bar. Now the target bar is the parent of all of the buttons. So what it's doing is it's going down through for each one of the actions that are listed. It is basically getting this is a for loop. So I'm going from 0 to the number of actions that I have, and I am instantiating an action bar button. I am getting the child of this node, which is the target bar. I'm getting the buttons, and I'm basically starting at 0, and I'm getting all the buttons, 0, 1, 2, 3, 4, as many actions as I have. And then I'm calling into that button, and I typically do this with most of my UI nodes. I have an initialize method. This isn't part of Godot. This is a method I created for the sole purpose of, in this case, allowing that one script that sits on all those buttons to know which button it belongs to. And I do that by initializing the action instance, passing that in, and then giving it the the button ID of the action, which is simply the list of buttons in the scene tree in the order that they appear, starting at 0. So that's why my loop is starting at 0. Very simple. I'm using the natural order of the buttons in the scene to populate the action instances that they are responsible for. And reset just basically goes through and clears those. There's a method in there to reset the button. And then there's another method to process the child button. And this is the object action engine process button action. That's the method I'm calling in to when I need to process a child button. Now I want you to notice this is 92 lines of code. And there's nothing in here in this code, this target bar. There's nothing in here about Flora. There's nothing in here about um, the objects in the game that I am working with. It doesn't care. It is responsible for doing one thing or maybe one or two things. It basically is listening for the engine to say, hey, we've got some new buttons. We've got some new actions to wire up to these buttons. And when the buttons respond back up to the parent and say, hey, I was clicked on, then it takes that information coming from that button, this method here, process child button, which is public. The child buttons call this method from the parent, or to the parent, excuse me. Hey, process me. I am button ID so and so, and I need you to process me. And so the object action engine, the purpose of the target bar is to pass that information over to the object action engine so that that button can be processed. All right, give me a second and I will be right back. All right, we're back. The process child button, I did a search, edit, find and replace, find in files, and I found here the action bar button. Now these are all the individual buttons, and this is the script that's attached to each one of those buttons. So we're going to take a look at that. All right, so this is the next step. The 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 parent, the button bar, or the target bar, it got notified that, hey, we've got this new action that needs to be wired up. So it goes through the process of instantiating the information it needs to pass to the buttons, and then it gets to the buttons and it says, okay, here you go. This is what you're responsible for. This script is attached to each one of those buttons. There's that initialize method that I mentioned. I set the button ID, the tooltip, the texture path. This tells me, where the image is that I need to show on the button, and then it loads the texture. So this is the button class. This is it. The action bar button. It is even smaller than the target bar code, and the reason is it's only responsible for letting everyone know, hey, I've been clicked on, so that it can pass that information back up to the target bar. The target bar can then pass it to the object action engine, so the object action engine can actually perform the action. So we've got a public method here, reset button. So this is called by the parent node, the target bar, to say, hey, reset your tooltip, reset your texture. You're no longer responsible for this particular action. You'll notice there is a press. Now this is the pressed event on the button itself, and I've wired up an override on this so that I can capture that. And what we're doing is we're setting the input whenever they click the button, and then we're passing back up to the target bar. Now this is the parent process child button, and it's passing to the parent its ID, the button ID. Now the button ID came from the parent because up here in initialize, we're setting the value of the button ID. Now again, how do we gain access to the parent node in this child node? Well, we instantiate a private property here called target bar, and there's my variable. And then in the ready, I have my target bar, and I say get node. What type is it? It's type target bar. And then I just use a relative reference to get, so I back up one level in the node, and then I back up another level in the node, and I get that node of type target bar. The texture rect this is how I reference the texture rect on the button itself in the UI. So I instantiate a texture rect here, and then I set that by saying, hey, get node texture rect. It's of type texture rect, and here's the name of the node, texture rect. And so we'll take a look at the actual UI and the layout of the UI in just a little bit. And of course, we're capturing the pressed event, and that's it. There's nothing else that the button is responsible for. So keeping separation of concern is very important. What is that? That's just a principle that that classes need to just know what they need to know. They don't need If they don't need to know it, there's no reason to put it in there. Let things do what they do. Let each class that you make, each method that you write be responsible for one thing. Let it do one thing and one thing well, not 50 things. Sometimes we can't help it. Sometimes design requires that we loop through things and we do certain things at certain times. But if you can get your code, your C# code, or GD script, or any other language that you're using, if you can get your code down to where each method is responsible for one thing and each class is responsible to do one thing very well, that's good design. That's a good design principle. You can't always do it, but try to do it. Think about it. Be thinking about uh, how you can make your methods just handle one thing and do it well. That's a good design principle to apply to our software development. Okay, so there's our action button bar, and I keep pausing because I don't want to jump. I don't want to waste your time jumping around. So again, I'm going to pause and we're going to set up for the next step in this process. I'll be right back. Just a second. Okay, if you're still with me, this is where it's going to get really, really fun, really interesting. So back up here at the target bar, we get a notice from the button that, hey, I've been clicked. So there's an action that needs to be performed against the object. So this process child button gets called from the button and it passes its button ID. And the target bar says, okay, I'm going to call into the object action engine. I'm going to call into this method here, process button action. I'm going to pass the ID. So here we go. So I'm going to control click on process button action. And this takes us back over to the object action engine. And we are using a really, really cool feature of C#, reflection. And say, what is reflection? Well, without going into a lot of technical mumbo jumbo about it, reflection simply allows C# to look at itself. Okay, it allows the language to look at an object and discover things about that object. All right, so what we're doing here is we're using reflection coupled with an interface to handle object actions. So if the player is busy, we're not going to do anything. So if the player has already clicked on one action and they want to click on another action, then they're not going to be able to do that because we're not going to process the button action if the player is busy. So if the player is not busy, that means we can process this button action. So the very first thing we're going to do is we're going to make the player busy. So in the player engine, I've got this Boolean player busy, and I use it in a lot of places to say, hey, the player's busy, don't do something. You can't do this yet because the player's already doing something else. All right, so we set the player busy to true, and then we get the definition of the actions, or the action that has been clicked on. So you notice the action definition dictionary. This is a dictionary that's loaded from a JSON file. I will show you that. It gets this current action instance. This is the single thing that happens. Click on the apple tree, so to speak, where we set that as the action instance. And so we're pulling from that the specific action that was clicked on. That's the button ID. And we are grabbing the action name. Okay. Do you remember when we talked about the Flora definition, where we have an apple tree and we have these list of actions? Okay, so what we're doing is we're saying, hey, this particular action has been selected, and we're going to our action dictionary, the current action instance action name. We're getting dictionary reference for that action name. Now, action definition dictionary is up here, and it is a dictionary that has a string key and an action definition. This is the object being stored in the dictionary. So if I click on action definition, you will notice that this is the information that I have for an action. This is the definition of the action, and this is what's going to be pulled in the instance of the action that's being performed. Okay, so we've got a key, how much does it cost for a successful action, how much does it cost for a fail, tooltip for the button, the button texture file path, the start message. Are you noticing some similar properties here? The button tooltip, yeah, that comes from the action definition. The texture file path comes from the action definition. A start message, a success message, a fail message. These are all the properties that define an action. This is what I'm going to use to create this action in the game. There's three possible result types: the success, the fail, the not possible. There's a sound effect for the success, one for the fail, and one for the not possible. Now, the action definition is in a dictionary in my object action engine, and it's action definition dictionary. Now, I want to show you this. This is if you want to use JSON in your game, this is a way that you can do it. So I have this action definition dictionary, and I have a class I wrote called JSON Factory. And in this particular case, I know that my key is a string. So I have this JSON Factory method called load JSON file to dictionary with a string key. I'm passing it the object type, which is an action definition, and I am referencing another class, a static class that has file path constants in it, string values that represent files. In this case, the action definition file, which is resources data action definition.json. So I'll show you this method real quick. The load JSON file to dictionary with string key. This is the method. This is a static method that basically takes the type coming in, and it knows how to load the file and instantiate the type. This is also using reflection here. Get the property of the key from the file. Get the value. This is the key value pair of the dictionary. All right, and then load it with the item, and that's what it does. And it reads a JSON file that has been configured where the JSON data looks exactly like the class that's passed in. That's the T coming in, the type. Okay, and then it loads up that JSON and it returns the dictionary back. In this particular implementation of JSON, I am using Newtonsoft's JSON library, and you can pick up Newtonsoft's JSON absolutely positively for free. And so I created a static class JSON factory so that I can have some static methods for loading different types of dictionaries. Okay, so you'll see, I've implemented an iList of T for load JSON file to list. I have one called load JSON file to dictionary, so I can load a file to a list of type. I can load it to a dictionary with an int key, dictionary with a string key, load JSON file to dictionary with a vector2i. The vector2i is the key that I use for my flora dictionary, because the key is the position of the plant or the tree in the tile map world, and of course that is a vector2i. So these are the different types. These are the different methods I created to handle different dictionary loadings using Newtonsoft's JSON. If I come up here and I look at my project here, okay, I have if I come down and say manage NuGet packages and I pull this up, you will see that I have Newtonsoft JSON loaded. So that's how you find Newtonsoft JSON. You go to your project, You right click on it and you say manage NuGet packages, and you can use NuGet to automatically download a safe, reliable um, Newtonsoft JSON library into your project. And then once you have it, you can then reference it using your Newtonsoft JSON and create a static class to handle your loading of the different file types. Okay, so there is your JSON library implementation right there. You can pause the video and take a glance, and if you want to do the same thing, you can do exactly what I've done, and then it'll give you a library that you can use to and it's in my infrastructure folder, the JSON factory. That's this class right here. Okay. All right, let me pause and jump back to where I was, and I'll be right back. Okay, here we are. We're back at the process button action in the object action engine. And we have loaded, we're referencing our dictionary. We're getting our action name from that. Let me show you the action definition dictionary, what it looks like. So I showed you the class. I showed you how I loaded the class from the JSON file. So let's come up here and let's take a look at that action definition JSON file itself. All right, and just take a quick glance. Now, all of these, this is what a JSON file looks like, and we have sets of key value pairs, and this is multiples of key value pairs. So we have multiples here. So we're building a list of actions. So the key in this case is the name of the action. There's these, so for break off bow, for example, there's a success tick cost. It costs, in my game, ticks are minutes. So for a success action, it's going to cost 10 minutes. For a fail, it's going to cost 3. The button tooltip is collect bow. The texture file, this is the image that I have for my tool for the button bar that shows the image I'm using for break off bow. This is the message that appears in the message area in the game. You search for a bow to break off the tree. Success message, you managed to break off. And this is just I'm using the caret as a substitution in strings. So I do this with my journal. I do this with other messages. If I want to do a swap of information, so I want to add some context. For example, you managed to break off 3 bow from the tree. So in my code, in my action, I can set the value for this little guy, and then when I report it back to the client, I can do a swap on the string, search for the caret, replace it with the value, and it allows me to insert information, context information based on the action that's being performed. So that's all that is. The failure message, the bow was infested with bugs and you realize you cannot use it. The not possible message, there is no not possible message. Now this is again another standard that I've added in my code where I'm saying, okay, if the message is a dash, it means that there's nothing to report to the UI. So these are just rules that I've invented myself for writing in my code, to use in my code to help me manage information and when to show things and when not. A bajillion ways of doing things. This is just one that I've done. Here's the success sound effect path so that I can play a sound effect. This is the fail and the not possible. Well, there's no not possible message, so there's also no not possible sound effect. So I just enter a dash and I can skip it. And that's it. Now this file, this action definition JSON file, it's going to get huge. There's going to be hundreds, if not thousands of items in, or thousands of records in this JSON file. So you might be wondering, well, aren't you worried about performance? Aren't you worried when you try to load this big, massive file? Actually, I am not, because JSON is blazing fast, and I use it everywhere. And the beauty of it is not only that it's fast, but that someone, if I do publish this game one day, the player will be able to go into the data file and tweak the messages and tweak the values and just play around with it. Do whatever. I don't care what these values are for the player. And so by providing JSON files, these are just text files, okay? They're just text files that are in a specific format. The format is called JSON, okay? And they can tweak them and do whatever, replace the sounds if they want to. I mean, it's, you know, so it's for me, it's a good thing to use JSON because it's player friendly, and it also is very easy to add records. I can just copy and tweak and save, and I'm good to go, and it loads. All right, so that's what the action file looks like. And okay, yeah, this is why I pause, because I need to be able to get to where I'm going to get to without boring you with clicks. All right, so here we go. We'll get back up here. All right, process button action. All right, now this is the good stuff here. Okay, so what I'm doing is I'm getting the action name. So I know what the action is. I know the name of the action. Okay, now this does, of course, require that all actions are unique by name, but that's okay. They are, and they will be. So there will be no two actions with the same name. So I'm getting the action, and then if I have a definition for that action in that JSON file, the action definition JSON, this is where we're using reflection to basically look at something and instantiate it. So the object to instantiate is a string value that is a combination of the full qualified path to my class. So this is my full qualified path. ASTS, struggle to survive, scripts, application, actions, and then I'm embedding a value here into my string, action definition dot key. So I'm getting the key. Now the key is the name. So I'm getting the definition key, and this string value, whatever the key is, added to the end of this is my full qualified class name. Now you'll notice here, this is my project, okay? If I go to properties, you will notice that this particular one, this is a class library, okay? It is a class library, and in this library, of course, I've got all kinds of settings that I can reference. But the thing about this class library is this class library sits in a domain. So if I go all the way up here to the top, this namespace here, this is my full qualified namespace for my classes in this DLL. So a project generates a DLL, a dynamic link library, and inside that library there are namespaces, and inside those namespaces are classes. So this namespace, ASTS scripts application singletons, object action engine, the full qualified name of object action engine is ASTS scripts application singletons object action engine. So I'm doing the exact same thing when I'm instantiating this action. Okay, I am trying to find my code. Here we go. Nope. Here we are. So the process button action, I am basically saying, okay, I'm going to instantiate an object. Well, what is the name of that object? All right. So we've got my struggle to survive project, and then this says scripts. Now it's a good idea to name your folder structure to match your domain, to match the namespace that you're using. Very important because it can get very confusing. Okay, but it says ASTS scripts application. There's application actions. There's action, and we were looking at break off bow. Here are my object actions. These are those classes. They're standalone instanced classes that do the job of whatever the action is responsible for. That's these guys right here. So the full qualified name of the action, if I had clicked on break off bow, would be ASTS scripts application actions break off bow. And if we look at break off bow, you will see the namespace ASTS scripts application actions break off bow. Okay, so that's what we're doing. We are instantiating. This is why I hate clicking back. We are instantiating that particular action. So the object to instantiate is that object. We're getting the type of the object. Type is get. We're getting the type of the object so that we can use that type to instantiate it. We're going to create an instance of the object type with this activator. Now this is from system, and it is used to activate or create an instance of an object. In this case, this is going to be an instance of breakoff bow. We're going to create the instance, but we need the type, so we get the type here. And we're typing it. What we're doing is we're saying, hey, if we try to create this instance and this instance is of type iObjectAction, then we're going to do something. Otherwise, we're not. Now, that's going to bring me into the subject of an interface. And so let me pause real quick and we'll talk about the iObjectAction interface. Okay, I just noticed my time here. We're at an hour and 1 minute. So I'll try to speed this up. I don't want to make my videos too long because I don't want to ramble and waste your time. Okay, so we're looking at the iObjectAction. Now, this is an interface. You might, if you don't know what an interface is a class. It begins with a capital I. It is of type interface. And this class basically does one thing. It defines methods that need to be in a class. It defines those methods, not the implementation of those methods, but the signature of those methods. So you'll notice in this iObject action that we have a void initialize. We pass in an action definition. We also pass in an action instance. We also have another method called perform action. Now, this initialize doesn't have any return value, so it's void, but the perform action does. It has a type return called action response. So we've got a method called perform action. It doesn't have any variables being passed in, but it is returning an action response. And then this guy there's a third method called queue_free this node. It has no return value as well. Now, when we say that, when we're checking to see if the action class, the breakoff bow, is of type iObjectAction, all we're doing is we're saying, hey, every action in the game every class that's an action must implement these three methods. That's all we're doing. We're identifying the three methods that need to exist in each one of these classes, because if you look back here, you will see that we're going to be calling the initialize, and we're going to be calling the queue_free this node. You see, we're going to be calling initialize. We're going to be capturing that return from perform action. So the instance is whatever the object is that we're initializing. Those methods all have to exist because we're going to be calling those methods. So you can imagine if we have a class in the actions folder here to perform an action, if it doesn't have one of these methods, then it's going to fail. So we instantiate it and make sure that it is of iObjectAction, and in order for it to be equal to an iObjectAction, it simply must implement those three methods. And then we're giving it a variable name, instance. So if activator create instance, this object type, the object type is part of the entire qualified name of the object, the breakoff bow in this case, is an iObjectAction. Here's my reference to it. Then what are we going to do? We're going to add it to the node tree. We're going to add this instance to the node tree. Now, I want you to notice, I am adding a child of type node2D. I'm not adding a child of type breakoff bow. Why am I doing that? Well, I do not need anything specific to break off bow in my node tree. I just need this node in the tree so that it will run, so that it will do its thing. It's going to be calling into other nodes, but it's going to be calling into singletons that are up high on the tree. It's not going to be doing anything that requires me to cast it as type break off bow. So if you look at break off bow, you'll see that break off bow inherits from node 2D. All I need to do is put it in the node tree. I don't need the specifics of break off bow in the scene tree. I don't need any of this stuff in the scene tree because it's not being interacted by any other node in the scene tree. But I do need it to be in the scene tree, and that's why break off bow inherits from node 2D. Now, you can inherit in C sharp, you can inherit from only one class, but you can implement as many interfaces as you want. So in this case, this guy needs an iObject action. He needs to implement iObject action, and this is how it happens by saying public partial class because it's inheriting from node 2D, so it's not a standalone class. It is part of node 2D, so it's a partial class, and it inherits from node 2D and it implements the iObject action interface, and this is how you implement it. Okay, now if I say I'm going to implement the iObject action, C# is going to bark at you if you don't implement it. So I have those methods. I have the initialize here, and it has the same signature as the interface. I have the action response return for perform action, and it has the same signature. The method has the same signature as the interface, and it also has the third one, which is the queue free this node, and it has the same signature. So as long as the signatures are the same, you have satisfied the requirements for implementing the interface. The interface doesn't care what's inside these methods, and that's what an interface is for. It is to define the method and the signature of the method, but it does not care what you're doing inside the method at all. It does not care. Okay, so we jump back over here, and we're going to add the child to the node scene tree as a node 2D. We're going to initialize it. We're going to get a response. So initialize is where we're passing in the information to the class. Response is we're capturing the response from the method perform action, and the show action is another method that we're going to call that is going to, it's in the action engine itself, and it's going to show all the responses. So it's going to grab the response coming back from the class, and it's going to pass in the button ID so it knows what to do. And then after that, this is kind of neat. I was thinking as I was putting this together, how am I going to get rid of, I've added this break off bow to the scene tree. How am I going to get rid of it? I mean, I've got a response here, and I didn't do an async await here, but I just basically, called the method. But when I call this method and I want this method to be performed, perform action in that break off bow, when it's done, I need to be able to get rid of it. So here's what I did. I just added to my interface the ability to call back in to break off bow and all these other actions after it's done to say, hey, queue free this node. So first we remove it from the scene tree when we're done. All right, so show actions gives the response, and that's down here. We'll look at that in a second. And then I remove the child. I remove it from the scene tree. So it's gone from the scene tree, but it's still in memory. So then I call back into the instance and I say, hey, instance, queue free this node. And what that does, there's the signature. And if we jump over to break off bow, you will see it disposes of itself. Queue free, dispose. And that way we get rid of it out of memory. Okay, so I'll jump back over here. Now that is the process button action. So now we're getting into the individual actions that we have in our action list, our list of actions. This is where we get into the specifics of the code when we say, hey, instance, whatever type you are, you might be break off bow, you might be dig up root, you might be drop, or any of these. I want you to go ahead and perform your action. Now, let me mention this. When I first started this, and sometimes I do this because it just helps to organize things. If you're not quite sure of how to do something, just do it. Just try it. Try it in any old way you want. And if it works, then you can go back and refactor and make things faster or better or cleaner or more reusable or whatever. Okay. So when I first did this process button action, I did basically, I looped through all the action names. If action name equals break off bow, then. Else if action name equals break off branch, then. Else if, and so on and so forth. And after 2 or 3 of those, I'm like, wait a minute, this doesn't smell right. How am I going to be able to do this? What is this method going to look like when I have 1,000 actions? It's going to look messy. And then that's when I thought, you know what? Let's use reflection and let's get the type, instantiate it, and if I can do that, then I can rip all that if then, all those if statements can be, and you can use a switch statement as well. Um, Actually, I think that's what I did. I think I started with a switch statement, um, and I switched on each one of the values. But anyway, I got rid of that entire block of code with this code. Now, this code never has to change because I'm going to build my dictionary, my JSON file with all of these actions, and I'm going to get the action name, and I'm going to instantiate the object using activator from C# from the language to create an instance of that type once I have the object type. And I'm going to make sure that it implements this iObject action, and I'm going to perform this action. This code is done. Unless I change the feature in some way, this code is done. It's going to do its job. And what it's going to do is it's going to call into the perform action method. I'll tell you what, I've ran really long with this. This is 1 hour and 12 minutes now. And honestly, I think I should probably do a second video. So I'm going to stop here. I hate to leave you hanging, but I'm going to generate this next video fairly quickly. In meantime, watch this video, go back over it, and think about the things that I've covered in the video, and look for the next part 2 in this uh, video series, little mini series, probably not more than 2 videos, but the idea of creating objects and actions is really cool. And in the next video, we're going to actually look at the implementation of these actions. And then after we look at the implementation of the actions, we're going to actually see in the game how this works and pull everything together in part 2. So thank you for your patience. Thank you for listening and staying with me in this pretty long video today. And until next time, I'm bound to be coding.